Okay, since stretches is just a review, what I'm going to do is I'm just going to go and quickly talk about the 4 scenarios that stretches will occur. Okay, now the equation that we're really going to, I'm going to be focusing on is y equals f of x. I mean, that's the original, and this is y equals f of x. Now, they're very specific. They give it to me as square root 4 minus x squared, but it's actually easier to do them with the equation. Let's do this without the equation. It's just fx. Like, I don't know what it is. It's fx. So it says, what would y equals 3 fx? Now, I think it's highly obvious that 3 does not belong with the x. Okay? So then it does belong to the y. But let's use some algebra to get it with the y. I would have to multiply, I would have to divide both sides by 3 to get rid of it, or multiply by 1/3. So if I multiply 1/3 to both sides, I will have 1/3 y equals fx. Now this step is crucial. Every question that I had last class was because people didn't do this first. Okay? So they neglected to do this step, and then they would just go to the answer, and they're not getting that answer, and it's opposite of what you said and the whole thing. I said, well, let's do it this way. Okay, I get, well, that makes sense now. Okay, well, you need to get in a habit where when you get one of these, you know exactly how to get all the y's to the y's, and then start. So this here, if you remember correctly, is a vertical stretch by a factor of 3 about the x-axis. So, what do we have to remember? If it's y, it's vertical. By a factor of reciprocal of the equation. Words are always reciprocal of the equation for stretches. And about the x-axis. What does about the x-axis mean? That's like AKA attached to. It's kind of like, I look at this as an elastic band, and it is attached to the x-axis. So what would be a synonym for these points? No, yeah, they're roots, I guess. They are invariant. Since they will not move, they are invariant. I will take every y and multiply it by 3. So then, now I got to keep straight in my head. For the picture, it equals the words. Okay? Because this is what's going to get mixed up. It's like, oh, I thought picture equaled the equation. No, pictures and the words are reciprocal of the equation. Therefore, picture is also reciprocal of the equation. So I will take every y and multiply it by 3. Now, the most significant y would be the vertex, which is 0, 2, will turn into 0, 6. And do you see, if you're multiplying all the y's by 3, that's why the x-intercepts stay the same, because that's where y is 0. 0 times 3 is still 0. Okay? So this would be a vertical stretch by a factor of 3 about the x-axis. Remember, about the x-axis also means attached to. Okay? It's nailed there, and if that's an elastic, that's where it's nailed down. So there's a whole unit right in that sentence. Or sorry, a whole lesson that we did in Grade 11. So first of all, get the y's with the y's. Remember that it is a vertical stretch because it's with the y. Okay? So there's so many things here that I would be like, how am I going to remember? That's vertical stretch because with the y. Make sure these two are, reciprocals. Those are things that in 4 months you will have mixed up. Look at your study sheet for 2 minutes and you'll get it all back. Okay? And that's not an exaggeration. Your study sheet will give everything back to you after you've read it once. You won't have to be relearning it. You won't be like, what? It'll be more like, I forget how this works again. That might be, but to look at that and go, I have never seen this before. I have no idea what this is talking about. That won't happen. You may need clarification, but that's about it. Now, this one here, we're just going to keep going. Y equals 1/2 fx. Well, again, that half is with the y. But I got to mathematically get it there. I just don't take a half and put it on the other side. I've got to multiply both sides by 2. So this would be 2y equals fx. So that is, again, a vertical stretch by a factor of 1/2 about the x-axis. Now, I know what we think of stretches, right? Stretches, things get bigger. If I stretch an elastic band, we don't think of a stretch as squishing something down, but you have to understand that is just a general word for we're going to either squish it or stretch it, okay? So what I'm going to do is I will take every single y and I will multiply it by 1/2. So when I do that, I will get this. And it's about the x-axis, so that is where it's attached. There's a lot of review in that one statement. A lot to keep straight. And not only do you have to keep that straight, you've got to keep your translation straight, your reflection straight, your translation straight. Now we're going to mix this into it. The good thing, depending I guess how you look at it, is we will use this throughout the unit. Why is that good? Because at the end of the year, you won't be visiting. Well, actually, I had to move trig. So trig isn't the last unit. I used to do it last because it was nice. We brought back the transformations unit again, but it'll be second last, which is still close enough to the end. Okay, now, again, what is the study sheet really for? You got to get everything beside each other to go, oh, that's why it's different. If you miss the subtle differences, then, like you can see, that's what I always try to capitalize on the quiz. I just like to make them subtly different because are they differentiating well? Have they mixed up all their rules? When I make them so close, are they themselves looking at, I don't know why they're different, okay? Because if you're on the diploma going, I don't know why they're different, that would not be a good feeling. And as you can see, that's happening, right? So that's got to catch it. Now, I'm hoping you look at this, y equals f of 4x, and you're going, okay, I really get why that's with the x. Okay? Like you mathematically, because it's f of, you can't even mathematically get that out. Okay? If it was an equation, you can. But this you can't even get out. There's no math to do. You can't divide by 4. So this is x getting replaced with 4x. Okay, I guess I should go back. I didn't ever do that here. This would have been y got replaced with 1/3 y And the substitution for the next one would have been y got replaced with 2y. Okay? Now in this one, x got replaced with 4x. So remember, x is a horizontal stretch by a factor of 1/4 about the y-axis. Okay, that means it's attached to the y-axis. And if we multiply, so here's the question, should we be multiplying by 4 or by 1/4? 1/4, because words match the picture. So I will take every x and I will multiply it by 1/4. Okay, so every x. So 2, 0. What happens if you multiply 2 by 1/4? You get a half, okay? So you know that that x-intercept will be coming to here and here, okay? Now, if you had y equals f of x, and it said replace it with 4x, what would it be? And you're just like, okay, I've memorized rules. I'm writing my diploma. Oh, what if I mixed it up? And we're both looking at this. There's no equation, so I can't test it on my calculator. But yes, you can, you guys. If you are saying this is a vertical stretch by, or horizontal stretch by 1/4, then you should be able to take any equation in the world. Say, you don't have to write this down, you can just watch, but say y equals x squared. Why do I like this one? Because I just know what it always looks like. Okay, that's y equals x squared. Now, if I do replace x with 4x, I should get that. So if I graphed it, you're going to see it's going to look something, like this, right? Is that a horizontal? Yeah, that's horizontal stretch by. Yeah, okay. Yeah, that's right. Okay. You just proved it to yourself. Because when you memorize rules, there's always going to be, you're going to be a little unsure. Like I memorized it. I had this thing into place. But did I mix it up? You make your own equation. You try it out. And not only will it maybe help you with that one, you're like, oh, I mixed those up. And then question 11 you better get to too because you did it twice. Okay? So that's actually test wiseness. Test wiseness is when you use one part of a test to help you with another one. That's just one of the factors of it. You need another way. If you only have one way to do a question in the diploma, that is unnerving. Okay? Make up your own question. Make up your own, function. Try it out. Okay? Well, next one. Y equals f of 1/3 x. Okay? So this is a replacement of x gets replaced with 1/3 x. That is a horizontal stretch. Again, by a factor of 3 about the y-axis. Okay? So about the y-axis means it's invariant there at the y-axis. So I'm going to do the words, and that is a vertical stretch by 3. That means I will take every x and multiply it by 3. 2, 0 should become 6, 0. Negative 2, 0. Negative 6, 0. Okay, again, I hope that's right. Why don't I try my go-to x squared and see if that works. I will in brackets. And that's another thing. Will you change your answer because you don't know how to use your graphing calculator? Would you accidentally put, well, y equals x, y equals x squared. Let's see what happens. Y equals, okay, that's 1/3 x squared. You graph it, and now you're like, that isn't what I have. I'll go change it. Okay? So if you don't know actually how to prove it correctly, then you will get it wrong. Anybody that changes a question on the diploma or on any test in math, gets it back, and then says, oh, I had B. I should have left it. That was like my first guess. Okay? This is not an exam where, 2 plus 2 is 8, and you do it, and you come back, wait, 2 plus 2 is 8. What was I doing? Okay? That's not where you go, well, I was always taught. The first one you pick, leave it. Okay? That does not apply for math exams. Ever. Okay? That's like, which president did this? You're like, I have no idea, right? Okay, go with the first one you pick. If you have no idea, go with it. But after you prove it, and now you're like, that doesn't even work. Okay, don't go, oh, but I was taught in grade 5. Whatever you have, whatever your first choice is, leave it. Okay, not a good idea. So now let's do a transformation here. Now, it drives me nuts when people say it's a vertical stretch by a factor of negative 1/2. Okay, you can't have a negative stretch. Ever. Okay, it's a stretch. Now this one here, yeah, you can say, oh, there's the negative stretch. No, there is a stretch in there and a reflection. The negative's always a reflection. You can't have a negative stretch. Will there be that choice in the diploma? Yes, there will. Who would pick that one? The guy that has not been in class all year that says, I'm going to try it. Why not? Because it makes sense. Negative stretch, I'm going for that one. I mean, I see a negative. So when you look at this, there is 2 substitutions that go on. Now, remember this from last year, okay? This is the order you should always do them in: stretches, then reflections, then translations. Now, you will be able to get away with doing RST, which works out QRST, maybe, but the R and the S can be interchanged. I just think it's easier to draw them if you do the stretch first, then the reflection. When you do the reflection, then the stretch, bad things happen. Okay? So let's do this one together. And I'm not going to use any smartboard stuff. I'll do it just like you guys have to do it, because I want you to know this process, because I think this is a good written response question on one of my exams. Like, draw this. What would it look like after? So I am first going to do my equation correctly. So that negative would come to the other side, and 3 comes to the other side, will be 1/3 y equals fx. Now I'm very confident that nothing belongs with the x. So the 2 things that happen is, number 1, I have a vertical stretch by a factor of 3 about x-axis. And you could say followed by, or just have number 2. Next would be a reflection in x-axis. Okay. Now, take it from me, because this is how I got all my questions wrong, is I know sometimes we want to skip the step. Look how much time I just wasted. I'm just going to get right to the question, okay? And 9 times out of 10, I'm looking at the answer going, what? And then I do the steps. Oh, okay, I get it now. So for myself, if I skip the steps, I get it wrong. So I do recommend doing this. Yep. Because of okay. That's a good question because I should have had that in my notes, okay? And then this is this. Now obviously you know what's coming, where you're going to have to be doing stretches, reflections, and translations all at the same time. But you did that last year, so you should be okay. And you know what? Like I said, you know, and I don't think you guys are first, second year, but grade 11 got way harder, but because of it, before 30-1, first time you ever saw any of this stuff. Okay? Now it's all review. Trig, half of trig, no trig was ever done in grade 11. You've done half of it already. So you guys put in the suffering in grade 11. So grade 12 has come down a lot, in my opinion. They basically didn't put anything in. They just took stuff out. Grade 11, they just shoved everything in there that was really hard, right? So if you made it through last year, you're going to make it through this year. Okay? The challenge is, can you do as good as if you were happy with it, or could you do better if you weren't? Okay? So this one here, let's draw it. Let's do a vertical stretch by a factor of 3. Now again, how can we translate this into a picture? So is it going to get wider, or am I going to make it taller? Okay, so to do that, always remember what your invariants are. So I'm going to stretch it about those points. What I do is I just deal with the vertexes, okay? I've got local minimums and local maximums. This one here, where I just drew that dot, that's called a local maximum. That is not your absolute maximum. Do you see this graph goes up forever? There is no absolute maximum here. There will be, whenever there's bumps, we call them we call them relative maxes or mins, okay? What's that? Anyone in calculus, you're going to get that out the yin-yang. But here, you just have to know that it's not really a maximum, this vertex. Okay? So, it is 8. 0.8, or not 0.8, sorry, about a negative 0.88. So I'm just worried about the y. 8 is going to multiply by 3. It's going to come all the way up to 24. Now, if I do that local or relative min, that would be negative 4 times 3 is negative 12. Okay, so it's going to kind of get a bit narrower there. It's going to come all the way up to here. You see this does not move. And up there. So that's why I do find it easier to do the stretch first, because now I can visualize the reflection quite easy. And all I'm going to do, like it's actually going to be as if it was on a rotisserie and the x-axis is like the rod, and we're just going to flip it. Okay? So to flip it, I will take negative 24, positive 24, it will come down to negative 24, and that negative 12 is going to come up to be 12. And you got to keep this stuff straight too. Again, I am not going to be changing my x-intercepts because they are invariant. Okay. So I'm just going to put like a 1 here and circle it, so it refers to the 1 to the side. And the blue is my 2. That's actually going to be the least significant part of any question on this. They'll want to know what would be the new minimum or whatever. It'll be vertexes they're talking about. But where it started, I'm just visualizing it got squished this way, so even my arrows will come in a bit. And the nice thing about this one, which you will not usually have this convenience, is you can put in, you know, x cubed minus 2x squared minus 5x plus 6, the original, and then do negative 3, and then brackets around everything, and you will get this picture. The diploma is usually not nice enough to give you ones that you could just put in your calculator nice, because that shows absolutely no learning at all. The guy that hasn't been here all year could get that one right. They don't want that. Every single question on the diploma, like I can honestly say that if you weren't there, I bet you wouldn't be able to, like, unless someone taught it to you somewhere else, none of it's common sense. Okay? I have had some students that in other exams have, you know, missed most of their classes and still did very well in the diploma. If, you know, like, look at the second part of the diploma. You have to read, you know, a selection, and then you get questioned on it. If you are a good reader, you are going to do very well on both parts. Usually if you're a good reader, it goes with writing. And so you can write some good essays. You can, I mean, you've kind of picked up the life skill through your whole life. You've read. Now in grade 12. See, and a lot of this stuff that I teach, you specifically will never use. It's actually just the neural pathways that you will. Okay? So will you be asked to solve an algorithm? Well, that's all every management position will be. You'll have 20 factors, and you have to make them all work. That is purely mathematical. Okay, you do not learn that in social studies. You don't learn that in English. Okay, it is all taking a bunch of stuff and making it all work. If you're making a building, you can just imagine the amount of things that have to be thought of to be able to make that building right. Every light switch is going, every light socket, all your duct work. It is extremely overwhelming if you think what goes into making just a house. So here's kind of the Reader's Digest version of everything that's going on. Just realize, do you see the absolute value signs? That means there is no looking at the negative sign. That is a different transformation. So there is no negative stretches. Okay, so again, all of these questions are, let's do C. So if we have y equals f of x, that's still that original, what would a reflection in the x-axis and a vertical stretch about the x-axis by a factor of 3? Okay, so we can take this, a reflection in the x-axis. What's the replacement for that? Okay, what's the replacement though? That would be the y goes to negative y, and a vertical stretch about the x-axis by a factor of 3, because they kind of mixed up the order on us even. But about the x-axis means is attached to. So vertical stretch, what's the replacement? Y goes to 1 over 3y. So when you're making the replacements, I mean, this is frustrating in marking exams. I see this step, and then you guys replace other stuff. So then I'm wondering, like, is it something you've memorized now at this point, or do you actually do the replacements? Because if you do the replacements, You might want to do them in two steps. Remember, we had y equals f x, so the next step would be negative y equals f x. Now if I take 1 or y and replace it by 1/3 y, that would be negative 1/3 y equals fx. So my final answer, get that all the other side, y equals 3 fx. Negative 3 fx. Okay, D. Take 10 seconds to come up with the replacements, and then I'm just going to ask one of you lucky people to give me just the replacements. You're giving me the bring it on look. No? Okay, so again, you don't have to go any farther than that, just the replacements. That's kind of the huge thing, because I'm assuming you can follow the next step just out of common sense. But the replacement isn't common sense. You got to know your rules. Okay, Aaron, what's your replacements? Okay, does that make sense? I would say it does. So now I'm just going to actually do that. Y is 4y, and x goes to 2x. Okay, so I just followed the directions. And then you just want to make it y equals. So I will 1/4 f of 2x. Now do you see when it's in this form, the 1/4 and 1/4 match? So that gets confusing to people, because the rules for y aren't reciprocals, but the rules for x are reciprocals. That's confusing. So you know what we do? Get with the y's, x with the x's, and know one rule. The words are always reciprocal of the equation. Okay? It makes life so much easier. It takes you probably another 10 seconds more to do the question, because you've got to get it that way. But it does prevent many of you from getting it wrong. So it is a worthwhile step. I am all for the most efficient, fastest way to an answer. Okay? I'm not trying to take that away from you. I'm just saying what happens when you take too many, when you skip too many steps, obviously I can assume that you're not happy with the wrong answer by doing it. Okay? Now this one here, let's just do 3C. So let's just go the other direction. If you take y and replace it with 6y, what would you be doing to the equation? What kind of stretch? What kind of stretch, though? Vertical stretch by a factor of 1/6 about the x-axis, and a horizontal stretch by a factor of 3 about y-axis. Okay. Now I just want everyone on their own to do question 4, and I'm going to call one person up here to do it. Okay, now I'm not going to bring somebody up that got it wrong, so you don't have to worry about that. But this is a tough question. This question here separates a class. Half will get it, half won't. And it doesn't look that hard. You're doing a horizontal stretch. Okay, is this making sense? Okay, so we're doing 1 to 7 Just do the A, C, E, G's. So it'll go quick. Again, I know I say this every time, but I'm not seeing it enough. Do the question, look at the answer. Do the question, look at the answer, okay? I know you're sitting there going, oh, but that takes time. I've had too many students do an entire lesson wrong and learn it very well that way. Okay, it's also, and I don't have many students to do this, but I do have a few, that they will do their study sheet before they start their homework, and then they look at their study sheet as they're doing it, it is a really good technique, because then you really learn your study sheet well. And if you know your study sheet well, you'll be in the test, and you will know exactly where that is on your study sheet. Okay? We all have a photographic memory. Some people obviously can look at it for 2 seconds and get it, but if other people are using that over and over again, I mean, how many people, have you guys done Chem 30 yet? Or are you on it? I mean, you do not have to memorize the periodic table. You know you're getting in there, but come on, after you used it enough, you always know what oxygen is, and you always know where this one is, and you know the molar mass, and all that stuff. Not because you sat down and memorized it, but just through using it over and over. Okay, let's get everybody done. Like I said, Fridays are great to have no homework. Mondays are even better.